Okay, welcome to the last of our videos on factoring. So this one is going to be on special cases. There's two special cases that we can look at, and this is the first one. What's special about this particular one here is you'll notice that there's no X case, there's no BX, there's nothing here. That X value is missing. But what you can notice here is that we have an x squared and a 16x. You could still do this the P and S way, that product sum way. Your product would be negative 16, but your sum would just equal 0. You could do that. But what we can notice with this one, to save us some time and become better mathematicians, is we can notice that x squared can be square rooted to give us x. So I'm just going to open up the brackets and put our first term as x. And what you can notice also is if you can square root 16, you're going to get 4. So I'm going to put this at the end of our brackets, that 4. Here, what we need to figure out is what the sign should be. If we multiply 4 times 4, we are going to get 16. And if we did negative 4 times negative 4, we would get negative 16. Sorry, we'd also get 16. But if we had positive 4 and negative 4, we would get our negative 16. And if you did FOIL, and you would see you get 4x for the negative 4x for the outside, and the inside would be 4x, those terms cancel each other out. And that's why we don't have the x term. This here is called the difference of squares, because these are almost like squares, but the sign's different. And we can apply this to any of these type of ones where we don't really have that x variable here. If we look at this one here, 9x squared minus 64, we can do that same method. Let's open up our brackets. Leave them blank for now. If we look at the first term, 9x squared, if we were to square root that, we would get 3x. 3x times 3x gives us 9x squared. So that's going to be our first term in our bracket. And if we look at 64, if we square root that, we're going to get 8. Then one of them is going to be positive and one of them is going to be negative. You can still, like I said, do the product sum method. Your product would be the negative 64. Your sum would be 0. You could still do it. It's just this is a much quicker way. And if you guys can start noticing these, that will save you time and move you on your path to become a better mathematician, which is what we are aiming for. And let's do another one here. Okay, we have 49y squared minus 44z squared. Now you're going to be like, wait a minute, miss. These have two different variables. Doesn't matter. We can still do this. So if we square root the first one, 49y squared, we're going to get 7y. 7 squared gives us 49. Y squared gives us, well, y squared. So we're going to have our first term, 7y, and our second term, 7y. Now for that next section, we're going to square root 144z squared. 144 square rooted gives us 12. And z squared square rooted gives us z. Again, we have one positive and one negative because we're difference of squares. And that's how we can get these ones pretty quickly. Again, like I said, you can try working through product and sum, but this will save you time if you can start recognizing these ones. Okay, so now we have difference of squares. Now we are going to be looking at perfect squares. So perfect square trinomials. So with this one, we are looking at x squared plus 12x plus 36. Now, you can, for all these, use product and sum versions, but we want you to start working on recognizing these different ones where we can see ones that could be perfect squares. This is a time thing. It makes it quicker for us to know and see these, but if you're not seeing what we're seeing with the perfect squares yet, that's fine. You can still do your product and sum method, but as you get better, you might start and practicing more. You might start noticing these a little bit more. So if I'm looking at this one right here, I can see that the square root of x squared is x, and the square root of 36 is 6. And if I do 6 plus 6, that gives me the 12. So I can rewrite this and open up my brackets to having x plus 6, x plus 6, which I can rewrite as x plus 6 squared. This is why it's called a perfect square, because you can just bring them together and square it. That's the example for this one here. You can see this by x squared, square rooted, and 36 square root. Okay, let's try another example here. So we have x squared minus 8x plus 16. If I do the square root of x squared, I'm going to get x. If I do the square root of 16, I'm going to get 4. Now 4 plus 4 gives me 8. But I got a negative 8 over here. Wait a minute. Negative 4 times negative 4 gives me 16. And negative 4 plus negative 4 gives me negative 8. Oh, this is a perfect square again. So I can write this out, bring out the brackets. X minus 4, putting this lovely information here into that bracket, close bracket. Same thing again. And then I know I can rewrite it as x minus 4 squared. Again, this is a time thing. It saves a bit of time. If you're not seeing it right away, that's okay. You can go with your product sum method. You can go with the Australian method. This is just another way as we're getting further along in our journey to become better mathematicians. This is one of the ways that we can expand and work faster and see things a little bit differently as we're going. All right, so that's the last of our videos on factoring.